So what we're looking at today and tomorrow, so we're going to be looking at this for 2 days, is systems of linear equations with 3 variables. So we're going to be solving systems of linear equations with 3 variables. And what the main way that we're going to go about solving this or finding the answers, we're going to use elimination. Now, before we really get into it, we're going to kind of visualize it and see what we're talking about with systems of 3 variables. Now, there's kind of 3 different solutions we can have, and a solution will be the ordered pair whose coordinates make each equation true. So what we're talking about is a point or a line that will be in all 3 planes, that will make all 3 statements true. We want to find the values x, y, and z that will make all 3 statements true. So there could be exactly one solution where all 3 of these planes cross at a single point. They only cross at one point. Now, it could be that infinitely many. There's a line. There's an equation of a line that all 3 go through. Okay? So it's either going to be a point, a line, or it's going to be the case where they don't intersect at all. And these 3 here are no solution because when they don't intersect, there's not a true point between any of them. There's not a point that all 3 share or a line that all 3 share. Then it's no solution. And we're going to look at these here. Now, solving a 3-variable system of equation. Step 1 is going to be to rewrite. We're going to rewrite the system in 3 variables as a linear system in 2, using substitution or elimination. Then we're going to solve the new linear system for both of its variables, substitute, and go there. Really, we're going to either use substitution or elimination twice, because we're going to first pick a variable that we're going to eliminate, remove from both equations, and we're going to do it again, and then work backwards. So here's our first example, which y'all can easily read on the note sheet, yes? Yes, I know. So I'd go on and rewrite these 3 down so that you have them somewhere on that page, because this is the first one we're doing. And I would say the higher you write them up on that page, closer to that core concept, the better. Nope, too far. Our first main step is we're going to eliminate a variable. So looking at this here, we've got to see x, y, and z, which one we want to eliminate first. And what I do is I'm going to look at these 3 equations here. I'm going to look at the top one, the middle, and the bottom one. Now, I notice that on the bottom one, y is by itself. Yes, there's not a number written in front of y besides -1. I'm going to eliminate y first. Y is going to probably be the easiest one to eliminate first. And thinking back to Algebra 1, when we did elimination, what we did is we tried to get 2 of the variables to have the same number in front of them, and we combined them so that they simplified out. So what we're going to do is, looking at these 3 here, I'm going to highlight this equation here. And the reason I highlight it is because we're going to use it to eliminate y out of the other 2 equations. We're going to use it to eliminate y out of the other 2 equations. So I'm going to write 4x plus 2y plus 3z equals 12 down here. And 2x minus 3y plus 5z equals -7. Because these 2 here, we're going to eliminate y from them, because if I can eliminate y, we will have 2 equations with 2 variables. Then what we're going to do is we're going to use those 2 to eliminate a value of x or y, or sorry, x or z, to get down to 1, because that's our goal. Because up to this point, we have never dealt with any method to where I can just solve for 3 variables. Even in Algebra 1, we never dealt with anything where I could just solve for x and y at the same time. The most we've ever solved for is 1, yes? 1 variable. So that's where our goal is. That's where we're aiming. So looking at this here, what do I need to multiply this entire equation by so that these y's are the same? I need to multiply by what? Just 2. So what I'm going to do is I'm going to multiply. I'm going to write this down here. I wouldn't write this down below it because I'm going to erase it. I would write it off to the side. Does that make sense? Because I'm going to fill stuff in here. So we're going to multiply 2 by 6x minus y plus 4z. We've got to multiply it on both sides. Because what we're using is a scalar. We're scaling this entire equation up by 2. Well, 2 times 6x is 2 times negative y is negative 2. And 2 times 4z is plus 8z equals negative 6. Any questions on anything we've done so far? Not too bad. First step's not too bad so far. And what I'm going to do is I'm going to put it right underneath this equation here. So you're going to have to rewrite it because, unfortunately, you don't have the technology to be able to move stuff on your paper. Because we're doing this so that these y's will cancel each other out. They're going to eliminate each other out. I'm going to erase this here. Eric, I'm going to pick on you. What do I need to multiply this y by, or this whole equation by, so that this y and this y are the same, have the same number? 3. So I'm going to do that again. But this time we're going to multiply it by 3. So 3 times 6x is 3 times negative y is negative. 3 times 4 is plus. And then we get negative 9. So again, we're multiplying by that scalar, so the y values, not so much the sign, I don't care too much about the sign, but the number is the same. The number in front of y is the same. So we have 3 and 3. So the operation we'll have to use will be different, because if the signs are the same, we're going to subtract. If the signs are opposite, we're going to add. So whatever operation, because some textbooks will say you want the sign and the number to be the same, and then you just subtract every time. I just get the same number. I do it so I get the same number. But you just have to keep track of if we're going to add or subtract. I just do this to separate the page so the two are separate so I don't get them mixed up. Now looking at this here, the signs are opposite, yes? So would I add these two together or subtract them so the y's become 0? 2y minus negative 2y is what? 2 minus negative 2. Well, the negative and negative become what? It'd be 4, wouldn't it? So what do we need? We need to add. When the signs are the same, we subtract. When the signs are opposite, we add. Because 2y plus negative 2y would be 0. 2 plus negative 2 is 0. Does that make sense? So let's do the rest of 4x plus 12x is x. These variables cancel just like we wanted. We wanted that. 3z plus 8z is 11z. 12 plus negative 6. So we have that done. Now we have an equation with two variables, yes? That is what we wanted, so good. We got that there. Here the signs are the same. So we would, when the signs are the same, we subtract. When the signs are opposite, we add. When the signs are the same, we subtract. When the signs are opposite, we add. So 2x minus 18x is going to be negative 16x. Negative 3 minus negative 3 will be 0, just like we want. 5z minus 12z is going to be negative 17z is equal to 2. So this was our goal. So we did it once. Yes? So far, this first step, would y'all say this was incredibly difficult, what we did? No. Step number 2. Y'all ready for step number 2? Repeat step 1. We're doing it again. Because again, remember all the stuff, all the math you've had up to this point, is there any way that we've done just taking an equation and solving for 2 variables? No, because we've only ever solved for 1. Not with an equation by itself, because there's too many ways, because a plane, all of the points on a plane will make the statement true. So it's too hard to pick a point or a line that would work. Now, as Eric just said, are the 16s already the same? We have 16x and 16x, yes? We don't have to do anything with these here. Now, I'm going to use, nope, I can't use my tech magic. So what we're going to do is we're just going to put them over the top of each other. 16x plus 11z equals 6. Negative 16x minus 17z equals 2. So we're going to combine these two so that and the reason we add is because the x's are opposite. When the signs are opposite, we add. 16 plus negative 16 is 0. We should always be eliminating one of these on each step. 11z plus negative 17z is negative, what, 6z? Yep. Now what we're going to do next is we're going to divide both sides by negative 6. And what do we get? Be negative. I'm just leaving it as a fraction. So negative 1.3 repeating is the same as negative 4/3. I love this. I knew something wasn't right. This right here. What is that? What is 5 minus 12? Is it 17? That was close. What is it supposed to be? 7. I'm glad I spotted that. Well, eventually. So 11 plus negative 7 would be, which is equal to, these numbers look better? And then what? We divide by? So, unfortunately, the numbers got a little messed up, but the process that we did doesn't change. That's what we're doing next. Because once we finish step 2, once we've gotten down, solve for the rest. So I'm going to erase this here because I don't have quite the space for it. Oh. Yep, so all we've been doing, none of these steps we've done so far have been too bad, have they? No, but there's just a lot of them. So we know z is equal to 2, yes? Do you want to use this equation or this one? Doesn't matter which. This one here. So what I'm going to do is 16x plus 11 times what? Now I have an equation with one variable, yes? 11 times 2. Then we would subtract 22 from each side. 16x equals negative. So 16 plus 6 is? So sometimes if it's hard to wrap your brain around doing that, I sometimes go the opposite direction. What plus 6 gives me 22? 16. You're good. And then we what? Divide both sides by? Be negative 1. If it was negative 16, x equals negative 16, then it would be positive 1. So far we found that x is negative 1. I'm going to write this on the sideboard. We don't know what y is, but we know z is 2. Okay? I'm going to erase all this here for that line. And there we go. So we know x is negative 1 and z is 2. You have 3 options. Pick one of them. Yep. The top one. So 4x. So it'd be, instead of 4x, we have 4 times plus 2y plus 3. Well, 4 times negative 1 is? 3 times 2 is?
So would you like subtracting that to 46?
Well, I'd combine them first.
Oh, yeah.
On the same side of the equal sign, so we can combine them. Negative 4 plus 6 is? Almost. Well, hold on, Eric. I'm gonna thread all 3 of those together. Yes, because we take the 12. We got. Yep. So we subtract 2. 2y equals 10.
Y equals 5.
Because when we divide both sides by 2, we get y is equal to 5. So our solution is going to be the point negative 1, 5.
So what you're saying is Eric's brain just worked faster than us two.
Yes.
Yeah, it really did.
It did. Yeah. So this here, how many solutions do we have for this problem?
3. 1, wait.
1. It's the point -1, 5, 2. Because this is the point where all three planes, all three of these equations intersect. So if you look back at the first page of the note sheet, do you see the one it's really faded out, has a black dot on it? Yes? So I'll go back into the slides. This one here, so this example here, that is what we have. This is the visual representation of that problem. That point, that black dot, is the point -1, 5, 2. That's where all three intersect. Okay? We're going to look at this one here. Now, what I look for when I look at any of these equations is I'm trying to find which variable will eliminate the easiest first. So here, I try to find one that has a 1 in front of it, so all three of these here might work. Y has that, Z. So here, none of them are a bad choice. Because I'm looking for which variable will it be easiest to make the other two. The top one has all three because I can pick X. If I multiply it by 5, these match up, yes? Yep. If I multiply it by 4, these match up. We're good. Same works for Y and same works for Z.
So what happens when it's not a 1 and it's supposed to
That means you're going to have to do different numbers. Then I look for which ones have common factors. So these here, so if you look for, like, say, they all had even numbers, I would use the one with even numbers because I can make 2 into 4 or 6, or kind of common factors. And sometimes if it's just they don't look good at all, I've just got to pick one and go with it. I got to just pick one equation we're going to use and go with it. Now, I have a feeling most of y'all want to use the top equation. Now, the one I pick and I'm highlighting here is the one that we're going to use to eliminate the other two. Eliminate a variable out of the other two. So I picked the one I'm going to use to eliminate the other two. And then again, just like the last one, I'm going to write the other two down. One thing I'm going to warn y'all to be careful with is once you pick a equation to eliminate a variable out of the other two, it cannot be one that we eliminate a variable with. So if I use this top equation here to eliminate, well, yes. Eric, do we want to eliminate X, Y, or Z first? It doesn't matter which. So we're going to do Y first. To eliminate Y out of these two, I can't have X plus Y plus Z as one of these here because we're using it to eliminate a variable out. We can't use it in two spots. You have to use it for both. Essentially, this one's getting used to eliminate. We're not using it to solve. Does that make sense? Yes? Mm-hmm. So since we're eliminating Y, what do I need to multiply this Y by to get the same as this one?
5.
Well, 5 for this one, but how about here?
Oh.
Nothing, right? They're the same already, aren't they? Y and Y. So for this one here, I can just go on and write X plus Y plus Z equals 2. I don't have to do anything there. And as Eric was just saying, yes, we're going to have to multiply this equation by 5 so this one lines up. So we're going to do 5 times X plus Y plus Z equals 2 times 5. Well, 5 times X is 5 times Y is plus. 5 times Z is plus. Equals 2 times 5 is 10. Any questions on this here? We good with this here? Yes? So what do we do with this? We take it and put it right under this equation here, yes? I'm going to erase this here. I'm going to do this one here first. Now, since the y's on this one on the right are the same sign, we do what? We subtract. When the signs are the same, we subtract. When the signs are opposite, we add. So here we're going to subtract. Four x minus x is 3x. Y minus y. Negative 3z minus z is negative 4z. And negative 6 minus 2 is negative 8. So we have 3x minus 4z equals negative 8. Now let's look at the other one. We'll do it to both. Signs are the same, so we 5x minus 5x. 5y minus 5y. 5z minus 5z. So everything on this side is 0, yes? 3 minus 10. Negative 7. When will 0 equal negative 7? What this is saying is that equation 1 and equation 2 are parallel. They're parallel to each other. Well, so going back to our pictures, this here, the third equation can't intersect the other two because there's not a point where all three intersect or come together. It is no solution. There's not a point or a line where all three will be true. So it's no solution. When you obtain a false equation such as 0 equals 1, we had 0 equals negative 7. In any of the steps, the system has no solution. As soon as we get a false statement, 0 equals negative 7, 0 equals 1, we're done. It's false. When you do obtain a false equation, but obtain an identity such as 0 equals 0, so essentially all the variables eliminate out and we have something that's true. So if we'd said, if it actually been, well, you're really only going to get 0 equals 0, what happens? The system has infinitely many solutions. It has infinitely many solutions. So at this step here, if we'd have not gotten 0 equals negative 7 here, if we'd have gotten 0 equals 0, it wouldn't have been no solution. It would have been what? All real solutions along this equation here. Along that equation there.
This thing needs to like scrap.
Yes. This will probably be the last one we do today. So looking at this here, do we want to eliminate x or y first? And which equation do we want to use, x, y, or z? Use the top equation to eliminate the bottom two? So we were saying x. I would do a different one. So y, 5y. So I'd look at the variables and see what they are. Because we could have stuck with y, and that would have been, we're going to have to multiply that by 5 to get the other one. Z has the same number in front of all of them, yes? Yep. That means I don't have to multiply it by anything. So we'll have this one here, x minus y minus z equals negative 3. 5y plus z equals negative 15. So Almost, the z is different.
Okay.
So here we have x minus y plus z equals negative 3. And since we've chosen to eliminate z, here z's, the signs are, so we add. Since the signs are opposite, we add. X plus x is 2x. Negative y plus negative y is negative 2y. Negative z plus z is 0. Negative 3 plus negative 3 is negative 6. Now let's look at this one here. So any questions on the first one we did? So let's look at the second one. So we have z and z, positive, both positive. When the signs are the same, we subtract. 5x minus x is negative 5y minus negative y. Well, the negative and negative make a positive, so we get minus 4y. These z's cancel. Get a negative and negative make a positive, and we get negative 12. Okay. So any questions on how we got to these two equations here? We good on this here? Okay. So what we're going to do next is we need to get one of the variables to have the same number. Do we want to use x or y? So what do I need to multiply this by to get to this one here? 2. So I'm going to rewrite this, as we'll need it. So we're going to multiply this equation by 2. So I'm going to do 2 times 2x minus 2y, and 2 times negative 6. Well, 2 times 2x is? Yep, so 4x minus 4y equals? Give y'all a second to write that down. The sign of x's are the same, yes? So we would subtract. 4x minus 4x is? Negative 4y minus 4y. Negative 4y. So we have negative 12.
Can we just write ARS?
All real solutions.
I'm sitting on this one. I'm good at that, but like this, subtracting both the same. Would that make that negative x plus 2? Or would it look like this? That's all, like, so that got turned into 2, so it's... Oh,
So we're done